travel agency claims, again, here's your claim, claims that the average cost in lodging for vacationing in Texas is less than the average cost, the daily cost in Virginia for the same type of vacation. So their mean cost for Texas, here's your claim. Your mean for Texas, we'll consider that 1, is less than your mean for 2. So we're going to make a chart. Texas, U1. This is 1, this is 2. The table at the left, they gave you the table at the left, only I neglected to give you the table at the left. So if you take a look at the table at the left, on page 423, your mean for Texas is 234. Your N in the sample was 25. And the population standard deviation for Texas, according to this, is $19. We're going to do the same thing for Virginia. The mean for Virginia, we'll call that X2, is 240. In their sample, they had 20. They're in the ballpark. They don't have to be exact. And their population standard deviation was $24. They're both normally distributed, so we know that that's good. We want to know, is there enough evidence to support the claim? Remember when we use the word support, that's an HA. And sure enough, that's my HA. My HO is greater than or equal to. So we do a test. What tail test do we have? Left-tailed, good, it follows the HA. We say reject H0. Fail to reject H0. We've got to find your cutoff point. Now that's your critical Z value. We're doing Z-scores because we know the population standard deviation. So you can go to inverse norm. You're only one tail, so you can see what inverse norm is at the 0.01. So put it in your calc, inverse norm, 0.01. What's your cutoff value going to be? Okay, good. This is our cutoff value. Anything less than that, we reject HO. Anything greater than that, we fail to reject HO. We're going to your calculator for this because the formulas are a little bit involved. To find the standard deviations, you have to take them, divided by the n, then you have to square them, divide by the n, add them together, take the square root, and then plug it into your formula. So we agreed we're just going to your calculator for this. So go to stat, come to test, we've got 2 samples here, 2 sample Z test. How do I know it's a Z? First we take, we have a population standard deviation. Good. Together we get this right. Together we're good. Okay. Now, notice it asks for your standard deviations right up front. So we're going to put in your population standard deviation of Texas. We take it right off your chart. Your population standard deviation of Virginia. Then we enter our Texas information. Make sure you try this because it's probably foreign since we didn't see this for 4 or 5 days. 240. Again, this one had 20. And follow your tail. You're less than. Then we're going to calculate. We're going to use your calculator only for this. We get a Z-score. This is your test statistic of negative 0.9. Z-scores have 2 decimals, so 0.91. This P, that's your P-val. Okay, so we get a P-val, and we get a Z-score for this. We bypass all those formulas. Good? Now we test. We say the Z-score of negative 9.1 falls to the left of the 0, but over here somewhere. So therefore, our decision is fail to reject H0. If you test P-val against level of significance, P-val would be greater than your level of significance. Again, same decision. Fail to reject H0. Your interpretation says, come up here. If you fail to reject your H0, can you support the claim? No. There's not enough evidence to support the claim at the level of significance of 0.01 that the vacationing cost in Texas is less than the vacationing cost in Virginia. Good? Did it all come back to you? Okay, so let's give you a set of problems for you to do. Are we good with this?
How do we find a Z-score again?
You want to do one more? Why do we find a Z-score? To see where it fits in your
No,
chart.
I mean, the inverse arm again?
To find your critical value.
Okay.
Okay, why don't you guys try it 3? And then we'll do book work. Try it 3. Let's everybody do this one. It's the same exact setup, same type of thing. Okay. So Nick, give me your claim.
U is greater than U2.
U1 is greater than U2. Good. And what is your U1? Which state did you use first?
Alaska.
Alaska versus Colorado. Okay, this is your HA. This is where your tail follows. Your U1 less than or equal to U2. This you always do. Make your tail test. This has to now be 0.05, inverse norm. Use the positive since it's on the positive side. Or use the 1 minus it since it's area to the left. Okay, now the rest put in your calculator. Use your chart and that will be helpful. So Alaska, it's the charts in the book. Remember, they don't have to be the same exact sample size, but they have to be within the ballpark. And your standard deviations were given in the wording for your population. Okay. Your rest and your calc. So pull up your calc. Go to your test again. 2 sample z-tests. Guys, they moved these around, so be careful. They switched them around on you. And now you've got 296. Okay, your tail also is reversed in this. You're now looking at a greater than. Just change your tail and calculate. So you get a z-score, 2 positions, and a p-val. You can go 2 positions or 3 on your p-val. You can test either one at this point, your p-val or your standard deviations, or your z-scores. So your z-score is falling over here somewhere, very close to the 0, and you fail to reject HO. If you test your p-val, that's greater than your level of significance, fill it with a 0. So if you fail to reject your HO, again, we cannot support the claim. There's not enough information or evidence to support the claim at a level of significance of 0.05 that the cost in Alaska is greater than the cost in Colorado. Okay, now don't base it just on your means. Your standard deviations throw a lot into that. That's a large part of your formula. Part of your formula is your standard deviations squared over your sample sizes. They're kind of combined, square rooted. So standard deviations have a lot of pull in this, as well as your numbers in your sample size too. We good? So here's your assignment. Write that down. 2 just the online keeper. We can punch holes